Good morning, students. So in this session we will discuss about the continuation of the last session, Z transform. So in the last session we have discussed about the importance of Z transform to analyze the DT signals and systems. So the transform in order to analyze the DT signals and systems in frequency domain, we use Z transformation. So which can be defined by x of z is equal to the summation of minus infinity to plus infinity x of n into z power minus n. So z is a complex quantity, z is a complex quantity, it's a complex quantity. So which is equal to r e per j omega. So the magnitude of z equal to 1, which is represented as a unit circle, and the angle is omega. Okay, and what do you mean by ROC? We have defined the region of convergence. So ROC, region of convergence, x of z, all the values of z, all the values for which the x of z is finite or converges. And the properties also we have discussed. Linear property, linearity, time shifting property, scaling property, differentiation property, convolution property we have discussed, and the properties of ROC we have discussed. The properties of ROC, before discuss about the properties, so we will define a pole. So how do you define a pole? So in the convolution, the output can be determined for any input if you know the impulse response of the system. So you can write the convolution function. This is a convolution. So if you take Z transformation, y of z equal to x of z convolve h of z. So the system function can be represented by the numerator polynomial is a rational function, numerator polynomial by denominator polynomial. So the numerator polynomial are zeros of the system and the denominator polynomials are poles of the system. Now how do you define a pole? So the system function has a pole at which the amplitude of the system becomes infinite. Okay. So which means what? The system out if you want the system to be a finite amplitude, we must avoid operating the system in the region of poles of the transfer function. So this is a transfer function, numerator polynomial, denominator polynomial. The denominator polynomials are known as are called poles of the system. So pole means the system has a pole at which what about the amplitude of the system becomes infinite. So the system becomes infinite, okay, if the system has a pole. The system has a pole at which the amplitude of the system becomes infinite. So it implies that the system output to be a finite amplitude, we must avoid operating the system in the region of poles of the transfer function. So now ROC, so now this in the Z plane you can represent okay, the unit circle, the magnitude as a unit circle, this is the angle omega. Now we will for simple examples, okay, we will determine the Z transformation, and if the system should be operated in the finite amplitude, then what about the poles? Then you can plot the poles and you can find out the ROC of the system. So in the continuation of the last session problems, now we will discuss another next problem. We will take x of n is equal to already we discussed u of n. Okay, so u of n we have discussed the u of n. For example, okay, we will take u of n. So what is u of n? U of n equal to 1 for n is greater than or equal to 0, 0 otherwise. So x of z is equal to the summation of n equal to minus infinity to plus infinity x of n into z power minus n. So this can be n equal to 0 to infinity, the x of n will be 1, okay, for 0 to infinity, then z power minus n. So this can be written as n equal to 0 to infinity z minus 1 into power n. So what is a power n, which is equal to 1 by 1 minus a, you know that a power n. So now 1 by 1 minus z inverse, you can write z by, so z minus 1. So in this, or you can say 1 0 at z equal to 0 and 1 pole at z equal to 1. Okay, the diameter polynomial coefficients. So now how do you define a ROC? So ROC you can define for the system to have a finite amplitude. The system should have a, because this is ROC means the system to have a finite amplitude. So this is your ROC. In that case, if you want to satisfy this condition, we must have this z minus 1 minus this denominator term 1 minus z inverse should be greater than 0. So 1 is greater than z inverse. So 1 is greater than 1 by z. So z is greater than 1. Okay. Now how do you represent this ROC in the z plane? Okay, so this is z is equal to 1. This is 1. So this is ROC. So this is your ROC. So this is modulus of z is greater than 1. So this is your ROC. Okay, greater than 1. If you want if the system to have a finite amplitude, the modulus the z should be greater than 1. So this is your region of convergence. In a similar way, we will take another problem, different problems. X of n is equal to u of minus n. Okay, so what is u of minus n? The immediate mathematical representation of u of minus n will be, this is u of minus n, correct? This is u of minus n. So what is the limits? So 0 to minus infinity. So this is the mathematical representation of u of minus. Now if you substitute x of z is equal to the summation of n equal to minus infinity to plus infinity x of n into z power minus n. Okay, now you substitute n equal to minus infinity to plus infinity, x of n is u power minus n. So u power minus n into z power minus n. Now, so the u of minus n to 0. So you can apply the limit n is equal to minus infinity to 0, this term will be 1. So is z power minus n. So this can be, you can write, okay, summation of, so minus infinity, so this can be interchange, n is equal to 0 to minus infinity, z power minus n, and if you change the sign, the summation of n equal to 0 to infinity, then the inside the sign will be changed, z power n. So 1 plus z squared plus z cube plus, okay, so this x of z is equal to 1 by 1 minus z. So if for ROC, we again the 1 minus z should be greater than 0, 1 is greater than z. So z is less than 1 for this function. So the ROC is less than 1. Similar way, now if you write next third fourth problem, if x of n is equal to a power n into u of minus n. So in that case again, so how to apply the limits here you should know. So what is x of z? The summation of n equal to minus infinity to plus infinity x of n into z power minus n. So what is x of n? N equal to x of n is a power n into u of minus n z power minus n. This is minus infinity to plus infinity. You know u of minus n will be, what is u of minus n representation just now we have seen. So now the limits n is equal to 0 to minus infinity, this will become 1. So you can write a power n z minus n. Next n equal to 0 to change the sign, then inside a minus 1 z power n. Then you can write this will be this can be written as n equal to 0 to infinity a inverse z of n, a power minus n into z power n. Okay, so a inverse z n, so a power n, so 1 plus a inverse z plus, okay, so this can be written as 1 divided by 1 minus a inverse z. So for again for ROC, the system to have a finite amplitude system, so every time the system in order the system to have a finite amplitude, this 1 minus a inverse z should be greater than 0, a inverse is z, so z by a, or z is less than a, you can write z is less than a. So similarly the other problems, so how to change the limits you should know. Okay, so the ROC is less than a, where the z values should be less than a. So similarly other problems you can take a power, fifth problem I will take a power n u of minus n minus 1 for example. So what is u of minus n, you know, and again it is delayed by 1. Okay, so this u of minus n minus 1, how do you represent the mathematical representation? U of minus n, okay, so you can write minus of n minus 1, so minus of n minus 1, it will be, this is minus 1, this is minus infinity, so this is 0, this is u of minus n minus 1. So x of z will be, so how do you represent summation of n equal to minus infinity plus infinity x of n into z power minus n. So this is x of n. So which is equal to summation of n equal to minus infinity to minus 1, minus infinity to minus 1, then a power n into u of minus n minus 1 z power minus n. So this can be written as the summation of n equal to, you can interchange the sign, so 1 to infinity, then inside it will be 1 a minus n z power n. So this can be 1 to infinity. So you can write summation of n equal to 0 to infinity, means this a inverse z power n minus 1. Okay, so this can be written as 1 plus a inverse z plus a inverse z square plus minus this minus 1 minus 1. So this can be written as 1 by 1 minus a inverse z minus 1. So simplify this one, 1 minus 1 plus a inverse z divided by 1 minus a inverse z. This will be cancelled. So you will get, this is z by a, this also 1 minus z by a. Okay, so now which is equal to, okay, that means this for ROC system, you know, this 1 minus again a inverse z, 1 minus a inverse z should be greater than 0. So 1 is greater than a inverse z, then z by a. So a, so again z is less than a in order to have a finite amplitude. Okay, the next problem. So some problems, the x of n, for example x of n into a power n u of n. Okay, so here the differentiation property, what is the differentiation property? Differentiation property, it says that the z transform of n into, for example x1 of n will get minus z d of x1 of z, okay, by dz. This is a differentiation property. You can apply this for the differentiation property. So a power n into, you know that a power n, so x of x1, a power n into u of n, already we, this is x1 of n, a power n. If x1 of n is equal to a power n into u of n, so already we derived a power n of u of n. What is the x of z for this one? 1 divided by 1 minus a z inverse, where the modulus of z is greater than a. Now x of n is equal to n into x1 of n. This is x1 of n. N into x1 of n. So now x of z is equal to, apply the differentiation property, minus z, z minus z into, so take z transformation this one to d of x1 of z by dz. So minus z dx1 of z by dz is, x1 of z is, what is x1 of z? There is x1 of z, so that is, this is x1 of z, okay, which is equal to minus z 1 divided by the x1 of z. So d by dz of 1 by 1 minus a z inverse. Now if we simplify this equation, so d by dz of u by v, v into du by dz minus u into dv by dz by v square. So you can write, so this is a, okay, a z inverse divided by 1 minus a z inverse the whole square if you differentiate. Okay, so this one if you differentiate, it is a d by dz of u by v. So v into du by dz minus u into dv by dz by v square. So again the ROC for this one, how do you define? 1 minus a z inverse should be greater than 0. So now z is greater than a. Okay. Similarly, you can now some more problems in Z transformation. Find the A values if given, no? Find the Z transform. So from the prescribed book, you can take the exercise problems. You can practice for some more problems and find out the ROC. So for example, 1 by 3 whole power n u of minus n, how do you determine? So if you take this example, take Z transform of this, okay, Z transform of a power n u of minus n. So you can rewrite a power n minus n e of minus n. So you can write 1 divided by 1 minus a inverse z. That is a power n into u of minus n. So a power n into u of minus n. So which is equal to 1 divided by 1 minus a is 1 by 3 whole power a inverse z. So where the z is less than 1 by 3. Okay. For this otherwise I'll explain one more shifting property. Note down shifting property here. The frequently used property, one more property of Z transform, shifting property. So shifting property is Z transform of u of n minus n. You can write, okay, Z minus n see the one of the shifting property here. The Z transform of u of n minus n can be written as z power minus n into z transformation of u of n. So you can write z minus n, u of n is 1 by 1 minus z inverse. So what is z transformation u of n? It will be 1 by 1 minus z inverse. So for that the modulus of z is greater than 1. So if the given problem x of n is equal to u of n minus u of n minus here n minus u of n minus u of n minus n. So what is x of z? You can write the z transformation of u of n minus u of n minus n. Okay. So what is the transformation of u of n? 1 by 1 minus z inverse. 1 by 1 minus z inverse 1 by 1 minus z inverse, where the modulus of z is greater than 1. Okay. So now 1 by, for this 1 by 1 minus z inverse minus u of n minus n. So that is, so what u of n minus n is z power minus n by 1 minus z inverse. You can common term 1 minus z inverse 1 minus z minus n, where modulus of z is greater than 1. Okay. So these are the different problems. Less than 3. 1 by 1 minus a inverse is z. So the z will be normally less than 1 by 3. Okay. So in a similar way, you can take u of n minus u of n minus a. Another problem, x of n is equal to 1 by 3 of n. We have instead of a per n, u of n minus u of n minus 8. Okay, if I give the numbers, so how you can write? So there is 1 by 3 of n into u of n minus 1 by 3 of n into u of n minus 8. You can apply the properties directly and you can find out the x of z. So what is x of z? So this 1 by 3 u of n is this. There is 1 by 1 minus a z inverse, is it? So what is a value here? 1 divided by 1 minus 1 by 3 of z inverse. So 1 minus 1, so for ROC 1 minus 1 by 3 z inverse should be greater than 0. So now z should be greater than 1 by 3, is it? Even if you want more steps, okay, 1 is greater than this plus 1 by 3 z inverse. Okay. So 1 by z is greater than 1 by 3. So you can simplify. The second one, z transform of 1 by 3 of n into u of n minus 8. Okay. So what is the meaning of this one? It is equal to 1 by 3 of n for n is greater than or equal to 8, 0 otherwise. Okay, 1 by 3 of n, u of n minus n is n minus 8 can be written as 1 by 3 of n, which is equal to this one. So now you can apply the limits, that is summation of n equal to 8 to infinity 1 by 3 of n. You can write this is z power minus n x of n. This is x of n. So this is x of n, which is equal to 1 by 3 of n, for n is greater than 8 to infinity. So now this can be written as summation of n equal to 0 to infinity means 1 by 3 z inverse whole power n minus 8. Okay. So now this can be written as 1 by 1 minus 1 by 3 z inverse a per n, 1 by A inverse minus 8. But for ROC, know that the modulus of Z should be greater than 1 by 3. Similar way, some more problems. How to find the ROC, how to find the stability of the systems. So, take x of n is equal to 1 by 2 for n into u of n plus 2 power n into u of n. So, what is the Z transform if we take Z transform? Okay. X of Z is equal to 1 divided by, for this one, 1 minus 1 by 2 Z inverse plus 1 by 1 minus 2 Z inverse. So, for the first case, the Z is greater than 1 by 2. This is another pole. So, the denominator here for this, the Z is greater than 2. So, now how do you draw the given system function? So, the first one is okay 2. So, the ROC for this will be 2 for the first case. So, second one. So, if I draw the first one, what is R? R is equal to 1 by 2. The second one, what is the R? Okay. This R is 2. R is equal to 2. So this is your ROC. Okay. This is your ROC. What is ROC? Okay. If the system to be a finite amplitude, that should be greater than 1 by 2. For this, the system has to be a finite amplitude, then that should be okay. So this is your ROC. This is your ROC. This is your ROC. Okay. So now I'll list out the conditions or the properties of ROC and the stability conditions I'll discuss. So how do you draw this final thing is, see, what is the ideal condition? This is your Z equal to, okay, for example, Z equal to 1 unit circle. This is Z equal to, this is R is equal to 1 unit circle. The one is R is equal to half. This is R is equal to half. This is R is equal to 1. Okay. So this is half. This is here 2, no. So in this case, it is 2. This is 2. Okay. For this system, so this system will be stable. Okay. So this is your ROC. This is your ROC. ROC. So this only this is causal for 1 by 2 per n and non-causal for 2 per n. Okay. For this is causal, this is causal but unstable. We classify now what are the conditions for stability, unstable under. So the system becomes stable. Okay, so how do you define a stable system? The system becomes stable only if the ROC of the system functions contains a unit circle. If ROC contains unit circle. So actually this is unit circle, we'll take this. This is unit circle. So in this example, what is the ROC? This is your ROC. But this ROC, this is your ROC. For this 2 per n, this is ROC. ROC does not contain the unit circle. So we can conclude that the system is unstable. It has two poles, one at 1 by 2, the other one it is a 2. Okay. So ROC defines the system to have a finite amplitude. In order to have a finite amplitude, so how the poles are located. So the Z is here greater than 1 by 2 is ROC, here the Z is greater than 2 is the ROC. So the condition for stability, the ROC contains the unit circle, but in this case the ROC does not contain the unit circle. Okay. So this region, this region is causal for 1 by 2, but it is non-causal for 2 power n. Okay. So you can refer opening PROCs for some more examples. Okay. So for example, if you take one more problem, x of n is equal to 7 into 1 by 3, I think this is opening problem, 1 by 3 per n into u of n minus 6 into 1 by 2 per n into u of n. So how we can write the summation of n is equal to minus infinity to plus infinity 7 into the x of n, x of z, you take x of z, this is x of n, 7 into 1 by 3 power n into u of n minus 6 into 1 by 2 of n into u of n, u of z per minus n. So how you can write? So this can be written as x of z of this function will be 7 7 by 1 minus 1 by 3 z inverse minus 6 by 1 minus 1 by 2 z inverse. You can write. So 1 minus So 1 minus, so the system to have a finite amplitude, the 1 by 3 Z inverse should have less than 1. If it is 1, no, 1 minus 1 0. It should not operate in the system to be in the infinite amplitude. Okay. So in this, for convergence, that is ROC for convergence, both should be, this and this should be, the modulus of Z is greater than 1 by 3 and the modulus of Z is greater than 1 by 2. Okay. So if there is 2 poles, then ROC is, which one will take? This one will take. ROC, the modulus of Z is greater than 1 by 2. So this is the conclusion, final answer. So how do you draw? So if you draw the Z plane, okay, so you can simplify this equation also. So you will get, if you take the common term, the numerator term by the denominator terms are these two, 1 minus 1 by 3 Z inverse into 1 minus 1 by 2 Z inverse. You just okay, can determine, you solve, you will get Z of Z minus 3 by 2 divided by Z minus 1 by 3 into Z minus 1 by 2 by 2. So the zeros and poles. So you can represent okay. So this will be greater than, so for example, it is 0, Z equals 0. The pole should be, so 1 by 3. So this is a unit circle. You draw the unit circle of the plane. Okay. Then 1 by 2. This is the half. 1 by 2. Then so this is 1 by 2. This is 1 by 2. This is 1 unit circle. The other one is 1 by 3. So how do you represent the poles and the zeros? So now if you list out the properties of ROC, the ROC does not contain any poles conditions. The ROC does not contain any poles. ROC does not contain any poles. Okay. So continuation of the last session, introduction about the Z transform. So different problems we solved in this session. So with this we can conclude the Z transformation and the properties of Z transformation and some of the standard forms of Z transformation. If the input is del n, x of Z will be, if it is the input is del n, x of Z will be 1. If it is u of n, then x of Z will be 1 minus Z inverse. Okay, that is the modulus of Z is greater than 1. Then if it is a power n into u of n, it will be 1 by 1 minus a Z inverse, where the modulus of Z is greater than a, and minus a power n into u of n, u of minus a power n into u of minus n minus 1. So 1 by 1 minus a z inverse, the modulus of z is less than a, and n into a power n u of n a z inverse by 1 minus a z inverse was squared. So the modulus of z greater than a, similarly minus n into a power n into u of minus n minus 1, a z inverse by 1 minus a z inverse. Okay, that is modulus of z is less than modulus of a. Okay, so one more session will discuss about the inverse z transform by using partial fraction method. So we can conclude with this in this session. So one more session will discuss about the inverse z transform, okay, by using partial fraction method. So you can refer the prescribed textbook, open him, practice, can take exercise problems, and you can practice. Okay, so it will be helpful, because here how to apply the limits and for the given function what is the basic deterministic signals, u of n, u of minus n, and u of minus n minus 1, and n into a power n, u of n, and what about the shifting property, differentiation property. So what is n into a power n u of n? So it is equal to a z inverse by 1 minus a z inverse squared. So here I also missed a squared. Okay, so using the shifting differentiation property. So hope you understood the z transform and how to take how to analyze the dt signals by using z transformation. Thank you.